Okay, so we started with talking about symbols, then we spoke about alphabets, and then alphabets made strings, and then finally strings got together and made a language. Okay, so this is what we basically talked about last week. So today we are going a step forward. Now, since we stopped at languages last week, we're starting with that part today. Okay, right. So now let's take the C programming language for example. We take an example, which is the C programming language. Okay, now when we take this language, let's say C programming language is made up of a set of alphabets, set of symbols. So these symbols will include A, B up to Z, and then capital A, capital B up to capital Z. Then there will be numbers, digits rather, 0, 1 up to 9. And after that, you will have some other characters. Okay, so this is going to be the alphabet of the C programming language. Okay, so this alphabet is going to be finite. At the same time, it's going to be non-empty. We discussed last week that an alphabet should be finite and non-empty. So these are the characteristics that will be applicable to the alphabet of the C programming language as well. Hari. Now the thing is, now when we take these symbols in the alphabet and get them together to create strings, like we discussed last week, we can create strings by a collection of symbols in the alphabet. Okay, when we do so, what do we come up with? Then අපි දන්න භාෂාවෙන් strings in a programming language will create programs. හරිද? මොකක් හරි program එකක් අපිට ලියන්න පුළුවන් alphabet එකේ symbols පාවිච්චි කරලා. So this is in automata theory we call this a string. In our normal knowledge we call this a program. Okay? So we can say that the C programming language is a set of strings. Last week we said a language is a set of strings, a collection of strings. So similarly, we say that C programming language is a set of strings where strings are programs. So let's say C programming language is a set of programs, and in front of programs I'm going to add another word which is valid. So this programming language is a collection of valid programs. There can be invalid programs as well. Invalid කට්ටියත් ඉන්නවා. Invalid කට්ටිය ඉන්නවා කියලා කියන්නේ there can be invalid programs which will give you an error upon compilation. Okay, so C programming language is a collection of valid programs. Now the question that we should get is, given a language and given its strings, given a language and given a set of strings, how can we say that this string is in the language or not? Given the C language and given a program Pn, how can we say that this particular program Pn is a valid program in C language or not? Let's say set S includes all the valid programs in C. Okay, so let's say this includes program 1, program 2 up until it includes all the programs which are valid in C language. Okay, so if we are given a program Pn, and if we are asked to check if this particular program is valid in C or not, valid the නැද්ද කියලා බලන්න තියෙන්නේ. valid එහෙම නැත්නම් මේක present C language එකේ මේ program එක present එහෙම නැත්නම් does C language accept this program? Okay, so this is the positive side. Negative side එකේ that program can be invalid, meaning it generates an error. එහෙම නැත්නම් it is absent in the language. ඒක නැහැ ඒ language එකේ define වෙලා. Otherwise I mean, if not, the program is rejected by C language. ඔය තුනම එකයි. ඔය තුනම mean කරන්න එකම දේ. හරි? Okay. So when we are given PN, program PN, how do we check if this is accepted by C language or not? What we can simply do is, now since we have a set of programs which are valid in C, what do? We check this PN against all of these programs. May PN waragena may set එකත් එක්කම compare කරලා බලනවා මෙයා මෙතන ඉන්නවද කියලා. හරි? ඉන්නවා නම් this is valid, otherwise this is invalid, rejected. හරිද? So there is a basic comparison we can do to check if a program is accepted by this particular language. So now since we applied this to C programming language, now I'm going to generalize this. අපි generalize කරනවා මේ කතා කරපු එක to all languages. So how do we do that? We say, given a language L and a string, how can we decide if the string is accepted by the language L? Okay. Earlier we spoke of this using C language and a program. Now we are generalizing it to all the available languages and all available strings. So given any language L and given any string S1, how do we check if S1 is accepted or present or valid in language L? Then හිතන්න අපේ alphabet එක A, B. Then say our language is strings of length 2. Okay, our language includes all the strings of length 2. Length 2. එහෙනම් අපිට language එකේ තියෙන මොනවාද? අපි ගේ සතියේත් මේක කතා කළා A B B A B B. Okay, right. Now say we are given a string S1. දැන් ඔන්න අපිට S1 කියලා string එකක් දීලා තියෙනවා. අපි කියමු S1 කියන්නේ AA. Okay, now we want to check if this particular string is present in L or not. So what do? Just like we did here, we compared PN with this entire set. Okay, so likewise what we're going to do is we take this particular string and we compare it against this set, the set which contains all the strings in the language. So we see in the very first comparison itself that this is present. So we say that S1 is accepted or valid or present. හරි. අපි තව එකක් දීලා තියෙනවා අපිට S2 කියලා, which says AAA. Then what do? We check this string against this set. We compare it with each element in the set and we see that this is not present. Make an set. So we say this is rejected by the string. It is absent or invalid. Now the thing is, we can do this comparison because this set is finite. The set of all strings in the language is finite. It's just 4. As long as it's finite, we can compare a given string against this particular set. Okay, but when the set of all strings in the language is infinite, for example, if our language is something like a set of all strings which start with A, එතකොට මේක යනවනේ දිගට A A A A B ඊට පස්සේ A A A A A B ඔක ඉවරයක් නැතුව යනවනේ set of all strings that start with A. A අකුරක් මුලට තියෙන විතරයි ඕනේ. So this set is infinite. If somebody gives us a string and says check if this string is available in the language or not, this is impossible because we cannot compare this string with this infinite set. Yeah. So that is when the problem arises. We have to come up with a presentation. We have to come up with a representation of the language which is finite, so that we can compare the string and say that, okay, this is accepted or this is rejected. Okay, so there should be a finite representation of the language. Whereas in these cases, when the language is infinite, we cannot use this method of comparison. Okay, right. So now what we want is we should have a finite representation of the language. Okay, we should have a finite representation එකක් තියෙන්න ඕනේ. එතකොට අපිට language එකක් දුන්නාම when we are given a language and when we are asked to check if a particular string is available in the language or not, using this finite representation we can say that yes it is accepted or no it is rejected කියලා අපිට කියන්න පුළුවන්. Okay, so given a language, how do we come up with a finite representation using which I can say that a string is present in a language or not? String is present in a language or not කියලා I can say using this particular finite representation. Is that clear? I hope that's clear. හරිද? දැන් මෙන්න මේ finite representation එක වටේට තමයි මෙතනින් එහාට දිගටම කතාව යන්නේ. Okay, this is where we actually talk about automata. මේ විෂය ගැන කතා කරන්නේ ඔතනදී. So what is this finite representation? ඕනෝකට තමයි අපි කියන්නේ මොකද්ද? Finite automata. Okay, this is where finite automata comes. So this has different names. This can be called finite automata or finite state machine. එහෙම නැත්නම් නිකං state machine. Anything. Okay, there are several names, different names to this. Okay, so what is a finite automata? A finite automata or a finite state machine is a finite representation of a particular language using which I can check if a string is accepted or rejected. එතන මේ වගේ infinite කට්ටියටත් අපිට පුළුවන් finite representation එකක් දෙන්න finite automata වලින්. හරි? අය බලමු කොහොමද මෙයාට finite representation එකක් දෙන්නේ කියලා. So our language is where we have the strings that start with A. කලින් ගත්ත එක infinite. This is infinite. Okay, so given a string we cannot compare and find out whether this string is present here because this is infinite. Okay, so what do? We come up with a finite representation, or we come up with a finite automata for this. Okay, now I'm going to draw the finite automata here. Don't worry about this diagram yet. Just to make a point. ඒක නිසා දැනට මේක ගැන හිතන්න එපා. මේක අපි දැන් කතා කරනවා. මේක මොකද්ද diagram එක කියලා. හරි? So don't worry about this for now. Okay. So to give you a basic idea of this, now do you remember last week we discussed මේ grammar එක define කරද්දී we discussed states, terminals, non-terminals ඔහොම එකක් අපි කිව්වේ. There's a state A, there's a state B, then you had a terminal බටයක් තිබ්බා through which you can go to the other state using a symbol of the alphabet. Okay, ඒක තමයි මෙතනත් වෙන්නේ. You have state A over here. මෙතන තියෙනවා state A, මෙතන තියෙනවා state B. A ඉඳන් B ට you can go when you meet simple A. Simple A is the alphabet. Alphabet එකේ තියෙන A B අපේ. States තමයි A B C. States එහෙම නැත්නම් different places that you can go. Okay, so then what this arrow says is මේ arrow එකකින් කියන්නේ උතනින් තමයි පටන් ගන්න කියන එක. Your journey starts there. හරි, ගෙදර ඉඳන් campus යනකොට ගෙදර තමයි පටන් ගන්න තැන. Like that. A is the place where you start your journey, and you should have noticed that A, C both look the same, whereas B has double circles. Okay, double circles කියලා කියන්නේ this is the final state කියන. ඔතන තමයි ending point එක වෙන්න ඕනේ. That is the campus, university. If if you are going from home to the university, that is the ending point. Okay, now this diagram, okay, represents this language. මෙන්න මේකයි දෙකම එකයි. හරිද? This is a finite automata, finite representation of this particular grammar language. හරිද? So now, since I have a finite representation, what can I do? I can since I have a finite representation, what can I do? Whatever this string given to me, string I can compare it against the finite representation and say, this string is accepted or rejected. Or infinite I don't have to work because I have a finite one. Okay. All right. So let's say I'm being given a string AAB. Now I should check if this string is accepted or rejected using the finite representation. Okay. So now monkey one then megula alphabet AB which means we go from one state to another. Okay, they are the people who take us. They are the terminals. So I start initially with state A. State A when I see simple A, when I see the alphabet symbol A, where do I go? I go to state B. Okay. Then again I have another A in the string. B වලින්දන් I A ව දැක්කොත් මොකද කරන්නේ? මේ බලන්න. B වල ඉඳලා A ව දැක්කොත් ආයිමත් B ටම තමයි එන්නේ. Yeah. So I am still at B. Finally I have B over here. So once I am at B, if I see once I'm at capital B, if I see the symbol B in the alphabet, I still come back to itself. Antama එයාටමයි එන්නේ. Okay, I come back to itself. So again, I'm at B. How we go in the flow chart. Okay, so now the thing is, A is my initial state. Okay, and B is my final state. Okay, so do you see that AAB string එක දිගේ යනකොට AAB තමයි string එක. Once I started with A and once I ended at B, I have gone from the initial state to the final state. While I was scanning through the string, I went from the initial state to the final state. Okay. Because of that, we say that this string is accepted by the finite automata or the language. Okay, which means string එකක් language එකකින් accept වුණා කියලා කියන්න නම් finite representation එකේදී we have to go from initial state to the final state upon scanning this entire string. String එක දිගේ යනකොට මම මුල state එකේ ඉඳලා final state එක වෙනකන් ගිහිල්ලා තියෙන්න ඕනේ. මැද හරියක නැවතුනොත් එහෙම ඒ කියන්නේ ඒක reject වෙනවා. For example, හිතන්නකෝ මේක ගියේ AB නෑ AC කියලා හිතන්නකෝ. AC කොහොම නම් ගියේ C මෙතන initial, that is fine. කොහොමද පටන් ගන්න එතන ඉන්නේ. End වෙන්නේ final එකෙන් නෙමෙයි. This is not the final state. C is not the final state. Then මොකක් හරි අපි මේ check කරපු string එක is rejected by the language. Is that clear? Is the screen clear to you? My screen, is it blurred?
Yes, madam, it's not clear.
Oh, yeah. let me how is it now?
Clear है मैडम.